students, in this question we have to prove that the determinant 1 x square 1 x square 1 is equal to 1 minus x cube whole square. So first we start with the left hand side where we have the determinant. We call it delta equal to determinant 1 x square 1 x x square 1. So before starting the question, as we have to solve it fully and then prove it equal to 1 minus x cube whole square, it would be great if we have a lot of zeros occurring in any of the rows so that we can open the whole determinant along with that row and the calculations would be easier. So our whole effort should be in that direction. First we apply that let R1 go to R1 plus R2 plus R3 because I see the same terms but in jumbled up manner in the three columns. This gives me delta is equals to 1 plus x square 1 plus x square again and 1 plus x square again, and the other two rows they are constant. So x square 1 x x x square 1. So since the first row has all the elements as 1 plus x square, we can take it out common. We get 1 plus x square times determinant. Since we took this common part out, we'll be left with 1 x square 1 x square and 1. Now the first row cannot be simplified further. We should be concentrating on the other two rows. We do C2 going into C2 minus C1 and C3 going to C3 minus C1. Because in the right hand side proof, we were supposed to get 1 minus x cube whole square. 1 minus x cube has this term as one of its term in the expansion. X cube minus 1 is 1 minus or x minus 1 into 1 plus x square. So overall we have to convert x minus 1 type of a term or 1 minus x type of a term. So we would be getting 1 plus x square as it is, which was common. Applying C2 minus C1, we would be getting 1 x square x as it is. This would give us 0, 1 minus x square and x square minus x. And over here we will get 0, x minus x square, 1 minus x. So we see that now 1 minus x is common in C2 and so is in C3. We can take that part common. We will get 1 plus x square as it is from the previous step. Taking 1 minus x constant from the column number 2 and taking the same 1 minus x common from column number 3. We are left with 1 x square x 0. So 1 plus x would be left over here and minus x would be left over here. 0, x left and 1 left. So this was the maximum we could take out common. So seeing these two terms together, I get reminded of 1 minus x cube. We write 1 minus x cube into 1 minus x bracket or determinant 1 0 0 x square 1 plus x x minus x and 1. Right. So on expanding along row 1, because it has two zeros, so it will be very comfortable and easy for us to do that. You would get 1 minus x cube into 1 minus x as it is, bracket 1 into the other two terms, which will be 1 into 1 plus x minus x into minus x, and the other two terms are 0 for the determinant. We get 1 minus x cube into 1 minus x into 1 plus x square. This gives us 1 minus x cube into 1 minus x cube, which gives us 1 minus x cube whole square. And hence proved this is the solution to our problem.